let's remember from last term what the goal of calculus was. The goal was to find the gradient of a curve. And we started off talking about the gradient of straight lines. We then went to discussing how the gradient is rise over run. And ultimately, we landed on the idea that for a curve, the gradient of a curve is actually the gradient of the tangent to the curve. And that's what I have drawn for you here. As you can see, that red line, that's a tangent, right? And we know that tangents only touch the curve at one point. And we wanted to actually find the gradient of this tangent. And of course, you know that in order to find the gradient of a tangent or a straight line, we need 2 points, don't we? Because if you think about the gradient formula, it's it's y2 minus y1 over x2 minus x1. We need 2 points for that, but unfortunately we only know 1 point, which is the point where it touches, right? And so the solution that we proposed last term was, well, let's actually use a different line. Let's use this red line here. This red line that you see there, that's passing through the curve at 2 points, right? This one and this one. Now, that's not a tangent anymore. Instead, this special line has a name. It's called a secant. And it's a line that intersects the curve at 2 distinct points. Now, hopefully you remember this diagram, and you remember what we did with it. What we did was we took that secant and we used it to approximate or to estimate the gradient of our tangent. Now, this estimation or approximation gets better and better when those 2 points get closer and closer together. How do we get those 2 points to get closer? Well, we decrease h, right? We let h approach 0. That was the idea. When h gets smaller and smaller, the secant will actually become the tangent, because those 2 points will get so close that they're essentially on top of each other. That's the idea. And I think last time I showed you an animation of how that worked, right? Sorry, I forgot to fill this in. And the gradient of this secant, we can find an expression for that, because we have those 2 points that we need. So if we look at this point up here, that's the point x plus h, f of x plus h. And this point down here, that's the point x, comma, f of x. And so y2 minus y1 over x2 minus x1, that's the gradient formula, so we're going to use that. So on the top we'll get y2 minus y1 over x2 minus x1. And when we simplify this, well, I can't really simplify the top, but the bottom, that simplifies to just simply h, because x minus x is just 0. And the key idea, remember, the goal is that we want this secant to become the tangent. And that will only happen if those 2 points get closer and closer together. And that's only going to happen if h approaches 0. And so that's where we use what we've done the last lesson and apply a limit to this expression. We want h to approach 0. Now, of course, that's not going to work immediately, because h is on the bottom. We can't sub in the limit straight away. But you'll quickly see that as we do questions, that we can actually simplify the top and cancel h out. That's the goal, right? So let's actually briefly have a look at the definition that we've just reached. So we've just reached this pretty groundbreaking definition that the gradient of our tangent, which is now what we call f dash of x, right? That's the gradient of our tangent. So when we say gradient function, what we really mean is the gradient of our tangent, right? But this function now, f dash of x, is given by the business that we just derived, right? The stuff that we just got, okay? Now this gradient function, or the gradient of the tangent, this is also sometimes called the derivative. And in order to find the derivative, we differentiate, okay? So let's actually think about how we do this, right? This is going to be a very important skill, so be careful to watch very, very closely. And yeah, let's begin, right? So here we are, we've got some function, and we always want to begin by writing the function down. Now, of course, it's already written down for us, but I'm going to write it down because that's a good habit. Now, we should know what f dash x is equal to now. It's literally up there in that red box. So let's write down that f dash of x is equal to the limit as h approaches 0, and all this business here. Now, what can I do to evaluate all that stuff? Well, I know what f of x is, but I don't really know what f of x plus h is. But I can find out. All I need to do is substitute x plus h into my function itself. Now, wherever I see x, I just replace with x plus h. So 5, well, there's no x's there. That stays as 5. Minus 2. Now, instead of writing minus 2x, I'm going to write minus 2x plus h, because that's what this function notation means, right? And so now I know this thing here, f of x plus h, I know f of x, so let's just sub everything in. So what I get is the limit as h approaches 0 of f of x plus h. Now, instead of writing that, we can write 5 minus 2 x plus h minus 5, and remember to include brackets here, divided by h. Now, on the top, hopefully you can see that I can just simplify that. So let's simplify the numerator. I'll expand, so I'll get 5 minus 2x minus 2h minus 5 plus 2x over h. Now, if you see there, I can cancel the plus 2x and the minus 2x, and the 5 and the minus 5 disappears. And so really what I'm just left with is the limit as h approaches 0 of minus 2h over h. And you see now we can cancel h. That's the goal, right? We can cancel h, so the h's disappear. And what I'm left with is the limit as h approaches 0 of minus 2. Now I can just sub the limit in. Now, there are no h's left, so this is just equal to negative 2. Right? And then I'm done. Now, you're probably thinking, wow, that's a lot of writing. That's a lot of working. And yes, you'd be correct. This is the expected working for sorts of questions like this. Right? This is what we call finding the first derivative, or finding f dash x using first principles. That's the key word here. This formula that you see there in the red box, that is first principles. The gradient function using first principles. We'll talk about what that will mean in the context of everything else a bit later, but for now, that's what it is. So I'm also going to go through part B with you, because I understand that this is a new concept and another worked example won't hurt. So let's do part B together. So let's begin by writing down our function. Let's also write down what f of x plus h is equal to. And notice that I'm just substituting in x plus h wherever x is. Let me write down my gradient function formula. And you know what? Before I sub it in, it might be a good idea to actually expand and see what we get. So we'll get x squared plus 2xh plus h squared plus 3. And I'm actually going to expand and continue expanding here. I'm going to get 2x squared plus 4xh plus 4h squared plus 3. And then now I'm going to substitute everything into my gradient function formula. So it's very important that I keep writing the limit as h approaches 0. That's a common mistake that students make, is that they forget to write the limit. So make sure you do continue writing the limit until you sub the limit in. Okay, so I'm going to run out of space here, but hopefully I will be okay. Plus 4h squared plus 3 minus okay. So hopefully you can see that. Now, if we simplify the top, we can see that the 2x squared will actually cancel out with the minus 2x squared there. The plus 3 will actually cancel out with the minus 3, because remember, when we expand the bracket, we'll get minus 3. And so what am I left with? I'm left with 4xh plus 4h squared over h. Now, if you stare at that numerator for a bit, you can see that I can actually factorize a h out of the numerator, can't I? So if I take h out, I'll get 4x plus 4h over h. This allows me to cancel h from the top and the bottom. And now, can you see that I can now sub in the limit? Whereas before I couldn't. I couldn't sub in the limit before because h was still on the denominator. And I can't sub 0 into the denominator. But now, there is no more denominator. So I can sub in 0 for h. And so this just gives me 4x plus 0. Well, plus 0 is just nothing. So the answer is 4x. And I'm done. So I hope that that was helpful. And I would like you to try your best by giving these questions a go. And I expect that most of you will be able to do A and B quite easily. However, for part C and D, it may be a bit tricky. And so, especially part D. And so I would like you to give your best shot, and I will return and explain the harder examples. All the best. Oh, also, I forgot, you might want to complete these textbook exercises for first principles. Thanks.